Hello, welcome to Mickey Techie. Learn as engineer, teach as champion. First of all, I would like to thank my family for their continuous support and encouragement of creating these kinds of technical videos in public domain. And I would like to thank my mentor, Professor R. Surendran from Government College of Technology, Coimbatore, for igniting me a spark of creating these kinds of technical videos in public domain. And I would like to thank Almighty my God for my good health and broad mind. And I would like to thank my friends, followers, my dear students and subscribers for their continuous support and continuously watching the videos. Today's topic of interest is applied mechanics. Here I would like to give an introduction about the applied mechanics. First of all, the applied mechanics, which is also called as an engineering mechanics, which deals with the study of different laws of mechanics as applied to the solution of engineering problems. So that is called an applied mechanics. So here we are dealing with some laws, natural laws, to solve engineering problems. So that is the thing of applied mechanics. We know that the engineering mechanics is subdivided into three types, three branches: mechanics of rigid body, mechanics of deformable body, and mechanics of fluids. We all know that the rigid body, it is an imaginary body. There is no deformation, so it is always in equilibrium condition. So for study purpose we use the rigid bodies to apply different laws, as well as we have to find the solutions. For finding the solutions we use rigid bodies, whereas in real case all the bodies are deformable bodies. That means if we apply a load, if we apply a force on a body, it tend to deform. Therefore all the bodies in real world is a deformable bodies. And these rigid bodies and deformable bodies are related with the solid mechanics, whereas the mechanics of fluid is a study, it is a science of studying the fluid behavior when it is subjected to rest or motion. So this thing we have to study for fluids. That is why it is called as a fluid mechanics or mechanics of the fluids. What else? So here the mechanics of the rigid bodies is furtherly classified into two branches, that is statics and dynamics. Statics means a body at rest. You have to notice this. A static is at rest. Dynamics is in motion. So this you have to clearly understand. Static means rest, dynamics means motion. This dynamics is furtherly classified into two types. One is kinematics and kinetics. Kinematics, generally dynamics means the body in motion. Here the force is not considered. Force is not considered. Here the force is considered. So this is the difference between the kinematics and kinetics. Here the body involved in motion, but without considering force, we are calculating the velocity, acceleration, time, distance, all the things have been taken care. Whereas kinetics, with considering the force, the velocity, acceleration, time, and the distance, all the things are being found, and the deformation, all the things. Okay, so this is the difference between kinematics and the kinetics. Next is the system of forces. The system of forces. The force is an agent which change or tend to change the state of the body. Here what I mentioned, the state of a body, either it is a rest or uniform motion of a body. So, a force is an agent can tend to uh, make the body at rest or make the body to move. So, this agent is called as a force. If I say this is a this is a stationary surface, here I am having a body. So pushing if I am pushing the body and tend to move in this direction, so this agent is called as a force. The force is equal to mass into acceleration. This is derived from the Newton's second law, and we know that the force is directly proportional to acceleration. How much acceleration we are giving, so that much force is being multiplied. If the acceleration increases, the force is being increases. So this is the understanding. Even mass is the constant. If we increase the acceleration, the force is being increased. Okay, so we know that the force is a vector quantity, which means it is having both magnitude and direction. The characteristics of the force is characterized by its magnitude, its line of action, and their direction. Magnitude of the force is denoted by a certain number. If I said earlier, if I want to move an object from here to here, I am applying a force. If I say 100 Newton, so this is the magnitude. If I am saying I am putting an arrow at the top of the body, so it is the line of action. So top of the body, the top of the body either it can move in this direction or this direction. I have to give this direction, so that is called the direction. So the force is characterized by its magnitude, its line of action, and their direction. So these three things are very very important for notating a force. Here the system of forces is continued. The system of forces can be subdivided in as shown here. I'm going to give a few glimpses that you have to understand. If I say coplanar, it is in a same plane. Same plane means coplanar. Collinear means same line. Concurrent means same point. Same point. Parallel means lines, forces are in parallel. If I say like, like means same direction. Same direction. So these five things you have to understand. Once again I am repeating: coplanar means at the same plane, collinear means at the same line, concurrent means same point, and parallel means both the forces are in parallel. Like means a same direction. So this thing you have to understand. Okay, if you remember this concept, you can easily understand. The system of forces are subdivided into two types. One is coplanar and non-coplanar. This is on the same plane, this is on the different plane. In coplanar, we can divide it into three types. One is collinear, that is forces are acting in the same line. Concurrent, forces are acting in the same point. Non-concurrent, the forces does not act at a point. Whereas non-coplanar means a different plane. So different plane does not have same line of action, same line of forces. Therefore, collinear is not coming here. And concurrent means at the same point, non-concurrent is at a different point. In collinear, it may be like or unlike forces. So same direction, if the line is having a multiple forces all in same direction means it is a like force, whereas the same line but one is in this direction and another force is in this direction, therefore it is an unlike forces. Whereas non-concurrent is a parallel or non-parallel. In parallel it may be a like force or non-like force. Similarly, in non-coplanar non-concurrent we have a parallel and non-parallel. Parallel, it is categorized into uh, like as well as unlike forces. So this is the different types of forces. When I say coplanar concurrent, the forces must be at same plane and it meet at same point. So that is our understanding. Coplanar collinear means same plane and the same line of action. Coplanar non-concurrent means same plane but it does not coincide in the same point. That you have to understand for betterment of your understanding. So next we are going to discuss about different theorems. So these system of forces are very important for those theorems. So parallel forces means like this, parallel and like and unlike. See, like forces, the direction is same. Unlike forces, the direction is different. But both are parallel. Okay. So next, the Lamis theorem. The Lamis theorem is for the coplanar force system. Coplanar means same plane, and coplanar concurrent is the best way of explaining or stating the Lamis theorem. So coplanar and concurrent. So coplanar and concurrent system of forces is acting and tend to a body in equilibrium. So here you can see if three coplanar forces acting at a point. So point means it is a concurrent. Point means it is a concurrent. The three coplanar forces acting at a point be in equilibrium, then each force is proportional to sine of angle between the other two forces. So what I have given, so here the forces, if I say P, Q and S are the forces acting on the same plane, and these forces are meet at a point. The angle between P and Q and S is the alpha, and P and S is beta. Q and S is alpha, P and S is beta, and PQ is the gamma. Here, as per the derivation, as per the statement, the force is proportional to sine of angle between the other two forces. That is, P is directly proportional to sine alpha. Here, the P by sine alpha is equal to constant. This is the statement is for all the three forces, therefore it can be indicated as an equal P by sine alpha is equal to Q by sine beta is equal to S by sine gamma. So this is the interest about the Lamis theorem. The Lamis theorem is only applied for three coplanar and concurrent forces which are in equilibrium. So this you have to remember. Okay, there is no horizontal and vertical forces of resolving. There is no resolving of horizontal and vertical forces in the Lamis theorem. That is also you have to understand. So next is the principle of transmissibility of forces. The principle of transmissibility of forces is said that if a body like this, okay, I'm applying a force on here, the intensity of force is same in this line of action. So if I said, if I mark F here, I can even mark F also here, the forces here. So the what it says, the transmissibility, the intensity of force on the line of action it will not change. That is the principle of transmissibility of forces. The force act at any point on a rigid body. It may also be considered to act at another point in the line of action. So the principle of transmissibility is having same intensity, same line of action, and same direction. So that is the thing you have to understand in principle of transmissibility. Next, the parallelogram law of forces. If the two forces are acting as the parallelogram, as the parallelogram having some angle, say I'm here it is P and it is a Q. These two forces these two forces can be represented in magnitude and direction of the resultant of diagonal. So the resultant of these two diagonal, the intensity of P and Q can be denoted as uh, a resultant or. Therefore, the two forces are resolved into one force, that is called a resultant, if the one force is converted into two or many forces, that is called resolution of forces. So these things you have to understand. So the two forces are converted into single force means the resultant. The resultant is converted into two forces, that is called resolution of forces. So mathematically the parallelogram, the diagonal is being indicated like this, or the resultant r is equal to square root of p square plus q square plus 2pq cos theta. So this is for the major diagonal. Okay, next is a triangular law of forces. The triangular law of forces states that if two forces acting at a point is represented by two sides of the triangle, it's taken in order that the resultant represents the third side of the third side in opposite order. If I say the two forces are acting in this direction, the resultant can be in this direction but opposite order. So this are in towards the point, this should be away from the point. So that is the triangle law of forces. We can indicate in a triangle. So this is a P and this is a Q. Therefore this is the R, the resultant. The next is the Polygon Law of Forces. So one thing you have to understand that Lami's theorem is for three-force system and the principle of transmissibility is for single force system. Parallelogram law is for two force system. Triangular law is also for the two force system. Whereas Polygon law, it is the number of coplanar and concurrent forces can be represented in magnitude and direction by the sides of the polygon taken in order that the resultant force is representing the closing side of the polygon in opposite order. So as like the triangular law, the sides is being more than 3, therefore it can be considered as a polygon law of force system. So with this I'm going to close the today's session of applied mechanics. I hope you have enjoyed the session. If you have doubt, please let me know in the comment section. I will put another video for clarifying your doubts. So with this, I would like to thank you for all for the patient listening, and bye bye from Santhosh. Thank you.